Now that you're hopefully comfortable with reading data from a file, it's time to talk about writing data next. There are a lot of reasons why you might want to write data to a file. These include storing user data. Data can be maintained across different sessions, which can be useful for saving game state or for shopping cart items in an e-commerce application. This allows users to resume where they left off. Logging application events to a log file. This helps with troubleshooting problems as well as monitoring. Storing configuration data. You can store settings that might change or be configured for different environments, as well as elements shared between different parts of an application. Exporting data for exchange of information. Sharing data is very common, and file formats such as CSV, JSON, or XML have evolved to support interoperability and communication between systems. Supporting offline usage in a file cache. Temporary storage in a file is one way to improve application performance. If the data is needed again, it can be loaded from the file instead of fetching it from a remote source or recomputing it. Likewise, data can be stored in a file if a user is working remotely. When they get reconnected to the server again, this data can be uploaded at that time. Generating file products. These products might include reports, invoices, or documents as needed by users. Some of the concepts of writing to a file are naturally similar to those of reading from a file. You use similar named classes, but instead of input stream, you work with an output stream, for example. There's a file writer class rather than a file reader class, and so on. We still open a resource when we're writing, but understanding buffered data becomes more important, as well as managing multiple writes to a single file from different threads. As with reading, there are different ways to open a file for writing, and I'll cover these shortly. In this video, I'll focus on writing text to a text file. I've created a new project called Writing Files. I've included the student engagement code from my streaming lectures in this project. You can get this code in a student.zip file in the resources folder. This code contains 4 types: the student class, the course record, the student demographics record, and the course engagement class. I've modified this code slightly from the code in the streaming lecture. I changed the toString method on student demographics. Here, I'm returning a comma-delimited list of the student's data rather than the default implementation that was there before. In the student class, I've added a method to get a student's engagement records as a list of comma-delimited strings, which includes student demographics as well. This code will let me quickly get as many random students as I want using a stream. I'll set this code up in the main method just to refresh your memory. Before that though, I'll set up a header that describes which order each data element is printed out in. I use a text block for readability. Each record will have a student ID, a country code, an enrolled year, an age, and a gender. I'll add the backslash here so a new line won't be included. Make sure there aren't any spaces after the backslash, otherwise it won't compile. A record will also have true or false if the student has programming experience, the course code, the engagement month and year, and engagement type. To create a student, I pass in the courses they enrolled in, so I'll first set up 2 new courses. I'll create a JMC course with a course code of JMC for the Java Master class. I'll do a similar thing for the Python. PYMC is the variable name and course code is PYC. Next, I'll be generating a list of random students. I'll set up a local variable for the students. I'll call generate using the supply method that's on the student class, getRandomStudent, which takes a variable argument of courses, so I'll pass both course variables. I'll limit the students to 5 for now. I'll collect the students into a list. At this point, I can loop through the random students, getting their engagement records. Each student will have 2 engagement records, 1 for each course. I'll first print the header out to the console. I'll loop through my list of random students and get each student's engagement records. The records are returned as a list of string, and I'll just print each record. Running this code, I'll get 10 records for the 5 randomly generated students. Since this data is random, it will be different every time I run it and different from your results if you're following along. Now, instead of printing this to the console, I want to print these records to a file. First, I'll comment out this code that writes to the console. To write this data to a file, I'll start by specifying a path with a file name and I'll call it students.csv. The extension CSV is very commonly used and stands for comma-separated values. I can make this extension anything I want, but this one is pretty standard and lets others know something about the content in this file, so I'll stick to that. I'll set up a try-catch block because I know I need it for an IO exception. Here, I'll call writeString, a static method on the file's class, passing it path and header. I'll loop through my student list. I'll call files.write this time, which lets me pass an iterable collection. That's my student engagement records. I'll just print any error I get to the console. Okay, this looks reasonable, so I'll run it. I won't have any console output, but I should see the student.csv file now appear in my project panel at the project root level. If I open that, notice what's here, only the last 2 records of the last student, the 5th student. Maybe that's not what you expected. What's going on here? Let's go back to the code and give it a closer look. First, notice that I'm not using a try with resources block and IntelliJ never prompted me to use it. That's because each of these calls to files.writeString or files.write opens the file, writes to it, then closes the file. The file resource doesn't stay open between these calls. Each of these files.write statements is both opening and closing the file resource. Because we didn't specify to the code what exactly we wanted to happen, Java selected its default options of writing to a file. Let me show you these on a slide. All available options are found on an enum in the java.nio.file package called standard open option. The default options for files.write methods are shown in this table. When you don't specify options, the file will get created if it doesn't exist. The file will get truncated every time you write to it, which is why we only see the last 2 records of student 5 in the content. And naturally, it's open for write, but you can open any file resource, either for reading, writing, or both. For my code, I have 2 options. If I want all my student data to get printed, I can pass all the data into a single write method, or I can specify a different set of open options. More specifically, I probably don't want to truncate existing each time. I'll start with the second option. I'll change my code, adding a new line, then passing another option from the standard open option enum. Here, I'll specify the append constant, which means any text that's written to the file will get appended to the end of file. Running this code, examining the student.csv file, I can see that all the data was printed, including the header. Still, it would probably be more efficient to create a single iterable object and pass that. This would make one call to the write method so that we're not opening and closing a file resource for every student. I'll comment this code out as I have it here, except for the path variable. I'll redo this code slightly. I'll again start with a try block. I'll set up a new array list called data typed to string. I'll add the header string to that list. Again, I'll loop through my students. This time, I'll call it all, so all the engagements records will get added to the list. Now, all my data is in one iterable collection. I'll pass that to the files.write method without any open options defined. I'll again catch the IO exception and print data about any error I get. Running this code again, I get the same results and all 5 of my students' records in the students.csv file. When using these write methods on file, it's very important to understand that doing incremental writes, as I did in the first code, is going to be pretty inefficient. There are other options for incremental writes. One of these is a method on the file's class that returns what's called a buffered writer. I'll show you an example of this next, first by setting up a try with resources block. I'll set up a buffered writer variable named writer and I'll get a new buffered writer instance from the file's class method, newBufferedWriter. I'll pass that a new path for a new file, and I'll call this one take2.csv. I'll start by writing my header. I'll loop through my students. Unlike files.write, this class's write method doesn't let us pass an iterable, so I have to loop through the records individually and write each record. Catching the IO exception, I'll print the exception info here. I'll run that. Now I can see I have a new file in project's root, and it's called take2.csv. Let's look at that. This looks like it only wrote the header, but if I scroll to the right, I can see that's not really true. My data, the student records, are all there. They're just all printed on the same line as the header. Getting back to my main method at that last try block. I'll add another write statement after the statement that's printing the header. I'm going to pause here after I type the dot, which should display all the method options I have. Notice that there really aren't that many. There are only a few overloaded methods for write. One takes an integer, one a character buffer, and one a string. Then there are overloaded versions of those that let you specify a starting offset and length, so part of your record or string would be output. There is, however, a new line method here, so I'll select that. I'll copy that statement and paste it under the write statement that prints each record. I'll rerun my code. Now, the take2.csv file is a lot easier to read and matches what I had in the students.csv. Are you wondering how a buffered writer really works? Let's end this video here and talk a lot more about the buffered writer in the next video. Make sure to keep this project open if you're going to watch the next video now, because I'll be picking up the code at this point. Okay, I'll see you in the next video.